Welcome, ladies and gentlemen. I'd like to present you the research of Rüdiger Thiemann and me on the topic Fostering Critical Thinking by a Gamification Approach. We are actually living in a world with smartphones and apps and virtual reality systems, and the advance in digitization on the one hand opens up many new opportunities in different areas, but on the other hand reveals how complex today's problems can be. And to be able to face these problems in the future, our school students need to be prepared with a new set of skills, which we call the 21st century skills. And two of these skills are critical thinking and problem solving. Although critical thinking and problem solving are already known concepts, it still lacks digital tools to foster these skills, especially on the school level. And another difficulty we have to face is that due to the high complexity of current problems, it is much harder to maintain student motivation on a sufficient level, so that the students can solve the problems. And therefore, we want to use the motivational effect that gamification elements provide. So the aim of our research project is to develop a digital learning environment which is motivating to the students through the use of gamification elements and which allows us to foster critical thinking skills and problem solving skills. Now I just want to give you a brief look at the theory behind the concept of gamification. Turning et al. Defined gamification as the use of game design elements in non-game contexts. So in our case, the non-game context would be the educational one. Based on that definition, Kim et al. Defined gamification more precisely as a set of activities and processes to solve problems by using or applying the characteristics of game elements. And here, problem solving is already included in the definition of gamification. But what is actually possible when using gamification elements? This has been shown in several studies, like Buckley and Doyle, for example, as well as Saylor et al. They found that the use of gamification leads to an increased motivation among the students. And Buckley and Doyle could also find, as well as Hamari et al., that gamification elements were able to increase students' learning outcomes. Based on these results, we hope to engage students into the learning process and spend enough time with it for good learning outcomes. In our digital learning environment, the students are guided through different problem-solving phases, which can be described on the model of Scherer, Messinger, Koppelt and Thiemann as understanding and characterizing the problem, representing the problem, solving the problem, and reflecting and communicating the solution. And if the students successfully ran through these different phases, they might be able to transfer their problem-solving skills on other related problems. In the first part of our game, which is called Mintown Tutorial, we just implemented the first three of these steps. The critical thinking skills and sub-skills we want to foster are based on the list of critical thinking abilities by Annas. The skills marked green are the skills we focused on in the first part of our game, and the skills that are marked blue are skills we at least partly implemented into the game. As for example, from the ability number 5, observe and judge observation, we just implemented the sub-skill of observation. Now I want to give you a short overview on our project Mintown, which is an expandable digital learning environment. Part 1, the Mintown tutorial on the left side, is designed as a general critical thinking and problem-solving training. Beside the critical thinking and problem-solving skills, in this part the player should also learn the basic controls of the game. The second part of the game will be based on the chemistry-oriented context, and as you can see, the idea is that there might be developed much more parts with other subject-oriented contexts, as well as for STEM-oriented contexts. And we hope that the students will be able to transfer the collected skills of the subject-oriented parts into other subject-oriented contexts. For the development of Mintown, we follow the model based on the FDDLE framework by Thiemann and Anaga, which is divided into 5 steps: the analysis, the design, the development, the quality assurance, and the implementation and evaluation step. In the first step, we decided that a role-playing game would be a good choice to represent a complex problem situation, which will allow us to foster the critical thinking skills along the problem-solving phases. Furthermore, it will give us the possibility to easily embed gamification elements. Before we went into the design step, we split the game into the 2 parts I already mentioned. On this sheet you can see, in darker blue, the steps for the first part of the game, Minton tutorial, where we chose to foster the aforementioned critical thinking skills along the first 3 problem-solving steps. After we conceptualized the first part of the game, we started developing it and later embedded the gamification elements. A prototype of this part is now already done and has been validated using the expert rating. Now I want to show you how the digital learning environment looks like. We use the software RPG Maker MV, which is a software to develop 2-dimensional role-playing games that are accessible via Mac, Windows or mobile devices. In our game, the player have an avatar. They are guided through the problem-solving process via quests. They have to talk to non-player characters to get information, and after they have reached the problem-solving phase, they also have to collect several key items to solve the problem. During the game, the player are getting visual and auditive feedback when they finish quests or get important items. So, the prototype of the Minton tutorial has been validated by an expert rating, where we asked the experts about their game progress, the addressed skills, the motivational effects of the gamification elements, and we also asked them to give us open feedback on the game. Now I will show you a few results of the expert rating on Minton Part 1. We asked 6 doctoral students to play the game. The mean effective playing time was about 42 minutes, and 5 of them were able to finish the game completely. In the open feedback, 2 experts suggested that collecting information was partly difficult because it wasn't clear which information was missing and where it could be found. We also got the feedback that although the quest and storyline are logical and well designed, a quest log as well as separated chapters would be helpful to provide visual feedback on the game progress. Regarding the problem-solving phases, the experts successfully recognized the 3 we integrated into the game, and 1 expert stated that the problem characterization step should be supported by graded learning aids. On this table you can see a selection of critical thinking skills where the application was confirmed by the experts. It has to be mentioned that the application of the skills we aim to foster were all confirmed by the experts. The basic skills 1 to 3 were at least partly confirmed, and there are some other skills that were obviously addressed as well. Another good result is that experts agreed on the motivational effects of all implemented gamification elements. Based on this expert rating, we can say that the prototype of Minton tutorial meets many of our aimed quality criteria. But due to the small sample size, our conclusion focuses on the open feedback, which gave us the information that the player needs more support, like graded learning aids, and that the gaming experience could also benefit from further improvements. So the next step is to improve Minton tutorial, which is followed by another expert rating with students of chemistry education, which hopefully gives us a greater sample size this time. And after that, we will develop the chemical part of the game following the development framework. And finally, when both parts are finished, we will evaluate them with a target group of 10th grade students. So thank you very much for your attention.